Hey guys, today we are going to be doing the last application of our sum and difference properties. So sum and difference properties day 3. And if you notice in our essential question, how do I find general solutions for composite argument equations? So actually what we are doing today is kind of combining everything. So we've talked about solving equations using the inverse properties. We did that in Unit 3. Then in Unit 4, we did the using it evaluating sinusoids that way, and now we're going to be doing it with the sum and difference properties. The only difference is really going to be here on the first step. So let's talk about what we're doing. So what we're looking for here, we're looking for the general solution, and then we're also going to be trying to find values on the interval, all the values. So it's kind of like when they asked us for the first 3 positive solutions. Okay, and so if I look at this equation, cosine x cosine pi over 4 minus sine x times sine of pi over 4 equals 1/2. Now the one thing that you notice about this is actually an expanded composite argument expression. So if you look and you notice that you have the same thing here and then the same thing here, then you can rewrite this as just something of a minus b or something of a plus b. So if I look at my formula chart and I notice that I have a cosine and a cosine together, which means that I'm going to be finding a composite argument of a cosine, and then since it has a minus sign in this equation in the expanded form, it's going to have a subtraction a plus in the other way. It goes opposite for cosine. And so my a would be x and my b would be pi over 4. And then it equals to 1/2. Okay, now at this point, these are the same steps that we took before. Remember, if you are trying to get cosine to the other side, you cannot just divide by cosine. You're going to take the inverse cosine of both sides, and that's going to get rid of it. So I'm going to take the inverse cosine of that side to get rid of that cosine, and then I'm going to take the inverse cosine of 1/2. And so what I'm really dealing with here is the inverse cosine of 1/2 equal to x plus pi over 4. Okay, now this is stuff we've seen before. Before we had to use a calculator because they didn't give us nice numbers, but this one you're not even going to need a calculator for because it's 1/2. So that's a value that's on your unit circle. So if you think about here, if we have cosine and we have a positive cosine, I'm going to have my first general solution up in quadrant 1. Okay, so I'm going to draw that triangle in quadrant 1 and figure out what that corresponding angle is. So cosine would be adjacent over hypotenuse, which would make this last side root 3. And I know that that corresponding angle would be, reference angle would be 60 degrees, or because we're over here in radians, I'm going to go ahead and make that pi over 3. And then remember, general solutions. So I have to make sure I'm adding in that plus 2 pi in. I'm saying it could be any angle that is coterminal with that first pi over 3. Finally, we go my right side, which was pi over 4. And now all I've got to do here is isolate the x. So if I take this and I subtract pi over 4 from both sides, this will get me my general solution. Now, you're going to have to do a little bit of finding a common denominator here. My common denominator would be 12, and so this guy is missing a 4, so I'd have 4 pi minus 12, and then 12, this guy's missing a 3. So my first general solution would be 4 pi minus 3 pi all over 12, so pi over 12 plus 2 pi n equals x. Okay, and so that is my first general solution. Remember though, on your unit circle, there are 2 places where your cosine could be positive. The other one is down there in quadrant 4. And so in quadrant 4, the easiest thing that we could do is just make that angle negative, or if you need to prove it to yourself, draw that triangle again. We would have the cosine is 1/2, and then this guy would be negative root 3, which would make that reference angle negative 60 degrees. Or if you went all the way around the circle, you could also use that one and use 5 pi over 3. Okay, so I'm just going to make that negative pi over 3 plus 2 pi n equals x plus pi over 4. Again, we got to subtract pi over 4 from both sides. Find that common denominator, and this one is going to be almost the same thing, negative 4 pi over 12 minus 3 pi over 12. And so that answer would then be negative 7 pi over 12 plus 2 pi n equals x. And so that's your second general solution. So these two equations are your general solution. This is part A. Both of these. Okay? And so, same idea that we had done in the past, we just had to make sure we, fixed it in the beginning. And then finally on part B, they ask you for values of the angle that would make this true between 0 and 2 pi. So remember, if I'm thinking about pi over 12, 2 pi would be equivalent to 24 pi over 12. So I've got to get those angles in between 0 and 24 pi over 12 because I'm in radians. So my first one is great. Pi over 12 is going to work perfectly. Okay, that one is in between those two. Now my second general solution is not going to work out because negative 7 pi over 12 is not within that. So I'm just going to go ahead and take negative 7 pi over 12 and add 2 pi, just like my interval tells me to do. And that would get me my second answer in that interval, which is 17 pi over 12. So part B would be those two angles. Okay, so you find a general solution, same process, you just have to take your original expression and condense it. Let's do one more example, and this one is going to involve tangent. Okay, so we have tangent of 2x minus tan of x all over 1 plus tan 2x, tan of x equals negative root 3 over 3. So this looks crazy. But if you look at your formula chart and look at the composite argument thing, you're going to notice that this looks very much like the tangent of a minus b formula. And that's why we like our formula chart. Okay, so if you look at that and it had that minus in the top, we're dealing with a composite argument that's subtraction. And so then if I look right here, the first argument is going to be your A and the second argument will be your B. So I'm going to go ahead and plug that in. I'm going to erase this real quick to save myself some space. Okay, so now this is actually just the tangent of 2x minus x, and it is going to equal all that business. And 2x minus x, well, that's not bad. That's just x. And so really this is something that we've done before. And I didn't have to really worry about that crazy stuff at the beginning. You just have to recognize that it's going to be a composite argument thing. So we are going to go ahead and think about getting that tangent all by itself, or sorry, the x all by itself. So I'm taking the inverse tangent of both sides. You cannot divide by tan. Root 3 over 3. And so now I've got to think about, on my unit circle, all of the places where tangent is going to be a positive, or sorry, that's a negative. I totally lost my negative in there, where tangent's going to be negative. So we have all students take calculus. Tangent is going to be negative over here in quadrant 2 and over here in quadrant 4. And if you remember, we had a shortcut right here where if you knew that this angle was right there and this angle was right there, instead of writing two solutions, we could recognize that these are just 180 degrees apart. And so you could just write pi times n instead of 2 pi n. So let's kind of see how that's going to work out. So remembering that my principal inverse quadrant is in 4 for tangent, I'm going to start in quadrant 4. And I'm going to go ahead and draw my triangle out. So I have tangent is going to be opposite, here's theta. Tangent is going to be opposite over adjacent, and then I can do the Pythagorean theorem and get this last side. So if I did that Pythagorean theorem in here, I would find that this is equivalent to 2 root 3. And this is not quite the ratios that we've seen in the past. However, this is one of our special right triangles. Because if you notice here, if I called this side is actually my shortest side now. If this was 1, this would be saying that this is the root 3, if I took root 3 divided by that, and that this is just 2. And so this is a 30, 60, 90 triangle. So remember, x root 3 is what we're looking for. And so at that point, we know that opposite the smallest side is your smallest angle, so that's a 30 degree. And since we went negative, we're going to make that negative pi over 6. And you can write plus 2 pi in, but again, remember, if you went all the way back up here to quadrant 2, all you have to do is add 180. And then this is super nice because there wasn't anything next to x either, so this is my general solution. Again, if you find 2 general solutions on tangents, you're not wrong. This is just the shortcut. So finally, we're going to go ahead and look for those first 2 positives. So that was part A. Part B, we want to find in between 0 and 2 pi. So again, we're going to be looking for values that are in between 2 pi with pi over 6 is going to be 12 pi over 6. So something that are in between those 2 values. Now if you look at your general solution, unfortunately negative pi over 6 is not in that domain, so we're going to say negative pi over 6 plus 1 pi, so 6 pi over 6. So my first solution would be 7 pi over 6. Okay, well, apparently I cannot add because it's definitely 5 pi over 6. What just happened? I don't know how to add today. Negative 1 plus 6 is 5. Okay, and then your second solution is just going to be that angle, that 5 pi over 6, plus 6 pi over 6, which is 11 pi over 6. I added correctly that time. Okay, and if you notice, those are in the correct quadrants. This one is in quadrant 2, 5 pi over 6, and 11 pi over 6 is in quadrant 4. Okay, so we're going to practice more of this tomorrow, and I will see you then.